Okay, so this is the pre-lab video for the pH indicator activity we are going to do in class tomorrow. So let's get started. So let's talk about a solution really quick. What's a solution? Well, it's a mixture where one substance dissolves in another. In my picture, here's a beaker of water. If I were to add some sugar and some Kool-Aid powder and get a spoon and stir everything together, the sugar, the Kool-Aid powder would dissolve within the water. And overall, I would have a pretty simple example here of a solution. It's a mixture where the sugar and the Kool-Aid dissolved within the water. So when we talk about solutions, some solutions turn out to be an acid on the pH scale, and some solutions turn out to be an alkaline or a base on the pH scale. So let's look at the pH scale. You might recognize here's our pH scale. And anything below the 7 on the pH scale is deemed an acid, and anything above a 7 on the pH scale is deemed an alkaline or a base. And 7 itself has a neutral pH. Well, what does it mean to be an acid? Well, it's a solution with a large amount of hydrogen ions and a small amount of hydroxide ions. And a base is really just the opposite. An alkaline is just the opposite. An alkaline or a base is a solution with a small amount of hydrogen ions and a large amount of hydroxide ions. Well, here's a picture of a solution right here. How do I know if this solution is an acid or a base? I mean, I just have this, beaker full of, purple colored liquid right here. How do I know if it's an acid or a base? What I can do is I can use a pH indicator. I can use an indicator to figure out what the pH of it might be, and this is going to get to the purpose of our activity today. So what are then pH indicators? Well, pH indicators are chemicals, substances that will detect whether a solution is an acid or a base. And in this activity, we're going to use 6 different indicators. One of them being phenol red, like the name implies, it kind of has a reddish color to it. One of them being phenolphthalein, it's kind of a clear, transparent color to it. The third one being bromothionyl blue, like the name implies, has a bluish color to it. And then we're going to come to some that you might remember from middle school. Blue litmus paper. Even though it's called blue litmus paper, it actually kind of looks like a violet color almost. Red litmus paper, and even though it's called red litmus paper, it almost has like a pinkish color to it. And then universal litmus paper, it kind of looks like a light orange color. And so the goal is to determine which of these 6 indicators will detect an acid, which of these 6 will detect a base, and will any of these detect both an acid and a base? Let's go into that in a little more detail here. So how do pH indicators then work? Well, here is a beaker of hydrochloric acid. HCl is hydrochloric acid. Now, I already know hydrochloric acid is an acid. The word acid's in its name. I'm not trying to learn, is hydrochloric acid an acid? Or is hydrochloric acid a base? I already know hydrochloric acid is an acid. Well, here's a little container right here with 2 little holes in it. What I'm going to do is I'm going to add a few drops of the hydrochloric acid using my little eyedropper here. I'm going to add a few drops into the left side of this container here. So I've just added some of the acid, some of the hydrochloric acid into that little hole right there. Well, here's a solution of sodium hydroxide. NaOH is sodium hydroxide. Now, anytime you see the word hydroxide, you can pretty much assume that that's going to be a base. So I already know sodium hydroxide is a base. I'm not trying to figure out, is sodium hydroxide an acid or a base? I already know it's a base. So what I'm going to do is take a few drops, take my medicine dropper here, take a few drops of the sodium hydroxide and squirt it into the other container, the other hole in the container. Well, now what? Well, now we're going to use red litmus paper because I think you're familiar with litmus paper more than maybe some of the other examples you saw a moment ago. So here's again red litmus paper. Even though it's called red litmus paper, it actually has kind of almost a pinkish color to it. So here's a couple pieces of red litmus paper. Now, if I dip these into the acid on the left and the base on the right, if I dip them into the acid and the base, how do these pieces of paper communicate with me? I'm being silly right now. Do they verbally talk to us? Does the one on the left say, I don't feel anything when it's dipped into an acid? Does the one on the right say, oh yeah, this is definitely a base? How do these indicators actually communicate with us? Because it's obviously not verbal, that's just silly. You might recall from middle school that there might be a color change. Watch the base. Watch the litmus paper on the right that's been dipped into the base. 3, 2, 1. Notice what happened. Notice how the color changed from that pinkish color to like a bluish color. That's an indication, and that's why we call them indicators. That's an indication that there's been a chemical change. So I now know that red litmus paper will turn colors when I put it into a base. So I can use, for instance, red litmus paper to identify if something's an acid or a base. Look on the look on the left side. If you put red litmus paper into an acid, then no color changed. So I know that red litmus paper does not indicate if something is an acid. On the right side, I know that red litmus paper does indicate if something is a base. So right now I know that red litmus paper will indicate the presence of a base based on the color change. And so the goal is going to be to determine, I have to go through all 6 of these, determine whether red litmus paper will detect an acid only, will red litmus paper detect a base only, or will red litmus paper detect both acids and also bases? I have to go through all 6 indicators to figure this out. So then I go through the other indicators. Blue litmus paper, will it detect the presence of an acid only? Will it detect the presence of a base only? Or does blue litmus paper detect the presence of not just an acid, but also a base? Same for universal litmus paper. Will it detect the presence of an acid only? Will universal litmus paper detect the presence of a base only? Or can universal litmus paper detect the presence of both an acid and a base? Same then for phenol red. Will phenol red detect the presence of an acid only? Will phenol red detect the presence of a base only? Or does phenol red detect the presence of both an acid and also a base? And then same for phenolphthalein. Does phenolphthalein detect the presence of an acid only? Does phenolphthalein detect the presence of a base only? Or does phenolphthalein detect the presence of both an acid and also a base? And finally, bromothymol blue. Will bromothymol blue detect if a solution is an acid? Or can you use bromothymol blue to detect if a solution is a base? Or can you use bromothymol blue to detect both an acid and a base? So these are going to be your tasks that you have in our activity in class.